Thanks, Laura. Yes, it's my pleasure to introduce Jack Christie. He's a herpetology intern here at Archbold, and he's originally from Oregon. He went to Oregon State for his bachelor's degree. He's had a lot of prior technician positions before coming here. Many skills building adventurous positions, I would say, as a king cobra tracker in Thailand. He went to Georgia and studied gopher tortoises, and then studied their close relative, the desert tortoise in California, in another position. But a common theme has been using radio telemetry in his work, and he really has a deep interest in movement ecology, which has carried through to his internship here. And one of the big goals he's also had for his time here at Archbold was honing his coding skills in R. And I think you'll see that you'll see evidence of his success with that in his talk. So before I turn that over to Jack, I just want to publicly thank him for his enthusiasm in all aspects of the Gopher Tortoise field work, which has been ongoing, rigorous tracking and capturing gopher tortoises throughout the year in all weather. And also he's been super helpful with our various outreach, with running scrub camp activities and doing awesome creative posts on social media about all the crazy things that gopher tortoises do. So with that, Jack, I will turn it over to you. And it looks like maybe you need to share your screen, or some kind of screen sharing has to happen here.
Okay.
Oh, I can see it.
Okay.
Yeah, thank you for that introduction, Betsy. Is everyone able to see the first slide of the presentation?
Right now I'm okay. There it is. Yay.
Okay. All right. Okay. Hello, everyone. Thank you for coming to my presentation. Really appreciate it. I hope you have as much fun listening as I did while making it. I'll be talking about the movement and behavior of female gopher tortoises as told in 3 parts. So yeah, let's just jump in. So first, what is a gopher tortoise? A gopher tortoise is a type of turtle that lives on land. Gopher tortoises live in the southeast coastal plain, especially in Florida, which is kind of their stronghold. Gopher tortoises and their close relatives are fairly unique in that they are some of the only tortoises that dig burrows. And as it turns out, that's super important. So not just for other organisms that use burrows as shelter, but it also affects gopher tortoises in some pretty interesting ways too. So for starters, they spend a lot of their time there, some estimating about 95%. So they use it to manage their internal temperature. So when it gets too hot, they go inside. When it gets too cold, they go inside. They also use it to avoid predation and other unwelcome interactions. You can think of it as kind of like a home base from which they carry out their daily movements and activities. They also often move between burrows, either by co-opting another tortoise's burrow, finding an abandoned one, or just digging one from scratch. They also live active social lives. Tortoises interact with some regularity and are known to communicate with visual, tactile, and olfactory cues. Male-male conflict, as well as male courtship with females, are well known. Those are well known. But there's also evidence that females interact with each other, sometimes even antagonistically, as we'll get into. So what is changing during this time period? So seasonal variation in movement could be explained in 2 contexts. External, so as temperature increases, so does their activity. As precipitation increases, so does the amount of food available to them, as well as internal conditions. So female gopher tortoises undergo hormonal changes during the nesting season, and this is likely to lead to changes in movement as well as changes in behavior. So I wanted to know 3 things basically. The 3 parts of this presentation are as follows. Are female gopher tortoises more dispersed during the nesting season? Are they further away from each other? Does movement increase during the nesting season? And do tortoises that live near to other tortoises behave differently when they're visited at their burrows. Oh. So part one. So I predict that, yes, females will be more dispersed during the nesting season. So our study site hosts an unusually dense population of gopher tortoises. And because it's so dense, I think that more interaction will lead to more dispersion when activity increases. Basically, as females are bumping into each other, they move further away to kind of reduce those negative interactions. I also believe that behavior driven by nesting itself is going to drive more movement, basically females searching for like a suitable nesting location. And one reason this might be is that if nests are too close to other nests, it might make nests easier to find for nest predators, such as raccoons and armadillos. Gopher tortoises, they incur a pretty high rate of nest predation. So anything to reduce that would be pretty beneficial. So to test this, I needed, oh yeah, more dispersed, right? To test this hypothesis, I needed two things. I needed movement data and a way of calculating the degree of dispersion. So the movement data came in the form of a long-term telemetry data set. I used 3 years of weekly tracking data on 36 different tortoises. And this was between 2018 and 2019. To calculate dispersion, I used the dispersion index, R, and I'll talk more about that now. So what is R? R is basically a ratio. It's not a super complicated equation, which is nice. It's basically the average nearest neighbor distance that we see compared to the average nearest neighbor distance in a randomly distributed population of tortoises in that same area. So what would that look like? So as if R is close to 0, we basically see that the individuals would be like really close together, like really clumped. If R is equal to 1, then it basically says it's a random distribution, right? It's equal to the distribution of nearest neighbor distances if the population is randomly distributed. And then if R approaches 2, it's basically saying individuals are as far away from each other as they can be. It very rarely reaches 2 in practice, but you see these higher values in situations where animals are like territorial, or if they just try to avoid each other. That's typically when you see values at that end of the spectrum. So let's talk about how I define seasons real quick. I define the nesting season as being between April and June. So most of the literature defines the tortoise nesting season as being between May and June. However, because we're at kind of like a lower latitude, it gets warmer earlier. And we actually see nesting occur here a little bit earlier, pretty much throughout April. So I decided to include that in my nesting season as well. I define pre-nesting as just the 3 months before this, post is the 3 months after, and mating season typically happens in like late fall. So I put that here as well. So those are my 4 seasons. So let's go back to the dispersion index. This is a map of the study area. All the points on this map are individual tortoises. And this is just like one snapshot, like one frame of time. The polygon is the area I used to calculate R. And this was made by to include 95% of all points, the 95% of all tracking locations of tortoises throughout the 3 years of tracking. On the next slide, I'm going to play an animation of all 3 years of those weekly weekly tracking data. And it's going to include a plot of the R value for each week. So when you watch it, just see if you can notice any trends, make your little, maybe make a prediction like, hey, I think dispersion is really high at this point in the year, something like that. So here we go. So keep an eye on the tortoises on the periphery. Do their movements seem any different than the ones in the center? Did it seem like they were ever more or less dispersed from one another at any point in the year? So yeah, so there we go. That was it. That was 3 years of tracking data. So let's talk about what we just saw. So here are the results. This is R plotted over the 3 years. Each point is the value over a week. So here it is again, with each year on top of the other. Each line is the value during a certain year. So as you can see, the dispersion index is actually not really higher than other seasons. Kind of a bummer. While this method was not able to detect an effect, it's still possible that Maybe there is dispersal, but it's like short term, and then they just go back to their burrows after they do what they need to do. Yeah, but if it does, I wasn't able to measure it using these methods. One interesting thing is that we actually see a lot of variance of this measure relative to other seasons during the nesting season, but I think that's better explained by talking about tortoise movement, which I'm about to do. So, all right. So although while the dispersion index didn't provide a lot of insight into seasonal dispersal patterns, well, I guess it did. It just said there weren't any. But it did actually give us a really useful measure. So the nearest neighbor distance. So instead of calculating it for the entire population, I calculated the average nearest neighbor distance for each tortoise. So basically, I split the tortoises into two groups, those with an average nearest neighbor distance, so near distance to the next closest tortoise, into two groups, those with a neighbor within 50 meters and those with no neighbor within 50 meters or a nearest neighbor further than 50 meters. So I call those groups central and peripheral tortoises. You can see kind of their distribution on the map there. So yeah, as you can see, yeah, those with close neighbors are really kind of congregated in the middle. I chose 50 meters as my cutoff because that kind of corresponds to a typical daily activity radius for tortoises. My thinking was that those below this threshold would be more likely to encounter other female tortoises more frequently. So yeah, so with that in mind, let's move on. So movement, love it. Hypothesis. So I kind of had two ideas when it came to movement. My first prediction was that I predict that females would move more often and for longer distances. I kind of think this for three reasons, things I've kind of already touched on, but changes in the weather should lead to higher movement. Females may be looking for suitable nesting sites and possibly for new areas with high quality forage after kind of like the rains start kicking in the early wet season. And then my second, yeah, that's how fast they move. I predict that tortoises at different densities will exhibit different movement patterns. That's something I expect to see as well, but I'll get a little bit more into that after I talk about the first hypothesis. So the number of moves per season. So I use that same tracking data from before to look at some movement metrics, starting with the number of moves per season. Here's the data again for all 3 years. Each point is how many moves occurred in that week. Here it is again year on year with some box plots to kind of cut through the noise. And lastly, here it is as a bar chart with each column, the average number of moves per season, and the lines, the number of moves in each year. So nesting season averaged around 100 moves, with the pre-nesting season about 70 and the others in between. So, okay, so we're seeing some differences, but are the results significant? Let's find out. So the results. So I predicted that yes, females would move more during the nesting season, and what did we see? So I ran a repeated measures ANOVA, which generated comparisons between the different seasons. And so season does seem to have an effect on move at a highly significant value. And I also looked at some pairwise comparisons comparing each season to the other. And this is what I found. I found that nesting season had more moves than pre-nesting season and possibly more than post, although that was not significant. And it was not different at all from mating season, statistically speaking. That's our table. And yeah, those are some of the details of the analyses. So let's talk about the average move distance. So I wanted to understand how the distance traveled by tortoises between burrows changed between seasons. For this, I looked at the average. So I looked at the average of the average move made by each tortoise during each season. So they all showed the same patterns as previously. As the previous slide. Very similar at least, but not exactly the same. So I predicted that they would move further during the nesting season. Again, the effect of season on the distance of moves was significant. And then the pairwise comparisons yielded similar, although slightly different results. Nesting versus pre-nesting was not actually significantly different this time. Though nesting versus post-nesting season, we did see a highly significant result. And again, there was no noticeable difference between nesting and mating season in the mating season. And again, here are the tables. So this is an effect of, so basically if these results are accurate, then there is an effect of season on these different movement metrics. However, what I find interesting is that the pairwise, when we look at the pairwise comparisons, that movement frequency was different in the pre-nesting season, and that movement distance was different in the post-nesting season. I would have expected these to be more in sync with each other, that as they move more frequently, they're also moving farther. And it indicates that basically the tortoises move less often in the pre-nesting season, and that they move shorter distances in the post-nesting season. So the second hypothesis in regards to movement is comparing those same movement metrics, but instead of really like caring about the effective season, I wanted to know if those were different between central and peripheral tortoises from the value that we the category that we created earlier. So I think these will move differently for a couple of different reasons. Basically, tortoises in those denser areas, those red tortoises, would have more burrows readily available to them, because where there's more tortoises, we see more burrows. And so kind of picture a scenario where you're a tortoise, you're out foraging, and then you're kind of minding your business, but then you see this like really nice burrow that's nearby, and you move in, and then there's the tortoise that was living in that burrow that was also moving around, and they go back to that burrow, and then they realize that, oh man, my burrow's been taken over, I've got to move as well. So basically, where there's a higher density of tortoises, they're moving into burrows more often, and they might even be forced to move when their burrows are being taken over by other tortoises. So if this is really what's happening, then I would expect tortoises in denser areas to move shorter distances and more often. So how did movement frequency vary with density? So I ran a repeated measures ANOVA with the density of tortoises as the between subjects factor and season as the within subject factor. So we failed to reject the null hypothesis that these two groups were different. However, it was marginally significant. And if we look at like the mean values, we can actually see they are higher every season, but because the variance is so high, statistically, we can't actually really say that they're different. But I'll let you make up your own mind. As with the other movement metrics, we see that season does have an effect on movement frequency as well. So these are the results of the movement distance between groups. So not every tortoise moved in every season. So I had to cut 9 tortoises out, but there was 5 central tortoises and 4 peripheral. So I don't think it affected the results much. So we ran the same test as before, and we found a significant effect on tortoise density and movement distance. It seems pretty clear this time. Although interestingly, season did not seem to matter as much. These findings are generally in line with my hypotheses about burrow availability and burrow takeover kind of driving differences in movement. Although another interpretation is that if density is influenced by habitat, which does seem likely, the tortoises might move shorter distances because they want to stay basically kind of like where they are. Maybe like there's like high quality food there and they don't actually want to move very far because that would take them out of the high quality habitat. Okay, so let's recap real quick. That was a lot of graphs through actually pretty quick. So let's talk about nesting season. Were tortoises more dispersed? They were not. Did they move more often? Yes, between pre-nesting and nesting season. No, in the other seasons. Did they move farther? Yes, between nesting and post-nesting, but not in the other seasons. And then as far as density goes, central and peripheral tortoises, which group moves more often? I'm tempted to say central, although that was not statistically significant. Although you can see that peripheral tortoises end up moving farther. So yeah, so what's going on there? Yeah, there could be like basically issues of like social dynamics where tortoises are taking over their burrows, competitive interactions, kind of generating like higher movement frequency. And these peripheral tortoises are just living a different lifestyle than the ones that occur at higher density. So part 3, the third part, possibly my favorite part, is behavior. So I wanted to know, how do tortoises respond to burrow visitors? So I thought that tortoises at different densities, those central and peripheral tortoises, would respond differently when approached by a tortoise. So I took inspiration from this quote by the ethologist Nico Tinbergen. He said, to understand an animal, you have to interview it in its own language. So I thought the best way to interview a tortoise in its language was with a model of a tortoise. And yeah, so I called this model Torty, and I took Torty to each female gopher tortoise still being tracked. And I recorded the behavior I observed at each, and I did this 3 times for each tortoise I visited. And so, yeah, so Torty interviewed his subjects kind of by shaking his head like this. That's how I interviewed him. Because that is how a big part of tortoise communication. So my field methods. So I visited each tortoise, and I kind of went through the same, routine at each tortoise I visited. As soon as I made contact with the tortoise, I waited. I head bobbed Torty, kind of like in the last slide. Waited. I approached halfway to the burrow entrance, and then I waited. Did another head bobbing. Waited. I approached the entrance, like basically put Torty all the way to the entrance and waited, and I collected basically just the different behaviors that I observed, and it looked a lot like that. To control for just sources of variation and bias in the data collection, I randomized the order that I visited each tortoise. I made sure to visit the tortoises during the most active periods of the day, basically not too early, not too late. I interviewed them when the tortoises were likely to be active. I also recorded the behavior with the GoPro and reviewed to make sure that I was scoring these behaviors correctly. It also came with some good footage. So so how did I define each encounter? So I was recording behaviors, and I scored each encounter basically based on those behaviors that I saw. I scored it as an active defense if Torty was rammed at some point. I scored it as blocking if the tortoise I visited wedged itself sideways into the burrow in the encounter. And I scored it as passive if the tortoise didn't do either of those behaviors. So each encounter can kind of fall into one of those 3 categories. But instead of telling you about it, I'd much rather show you. So this is what a passive encounter looks like. You can see Torty makes his final approach here. And I'm kind of shining a light with my phone so that I can actually see in there. That was something I did a lot. You kind of just see a tortoise kind of just sitting in there, not really doing much. So I would have marked that behavior as inactive, and that encounter would have been scored as basically a passive encounter. So this is an example of blocking. I think this is something really cool tortoises do. You can see as Torty makes his final approach, the tortoise turns itself sideways and kind of braces its legs into the sand. And that actually makes them really difficult to move. And she almost pushes herself all the way out of her burrow, which I just find it's very charming. So the last and probably my favorite, to be honest, is an example of active defense. So as Torty makes his final approach here, you can actually kind of see inside the burrow. And at first we see what I scored as a withdraw. The tortoise pulls its legs in and then makes a pretty quick approach, and then just beats the heck out of Torty, just rams him all the way out of the burrow. 332, she's saying, you got to get out of my burrow. So basically all tortoise encounters fell into one of those categories, and those were kind of like the archetypical behaviors that embodied those categories. So what were my results? So let's see. So this is what we would expect to see if there was no effect, if there was no difference between central and peripheral. Little contingent table, right? We have central and peripheral tortoises, and how often we would expect them to show each behavioral response. However, that's not what we saw. We actually saw that central tortoises were much more likely to give an active response and a lot less likely to block. And we saw the opposite pattern in peripheral tortoises. So on paper, it seems like we're seeing a significant difference. Central tortoises, were again much more likely to block, much more likely to actively defend, basically ram. And so yeah, so this is, preliminary analyses, and I'm still working out the most appropriate test because, it is a small sample size and the data was repeated for each tortoise 3 times. But yeah, but preliminary analyses seem promising. It seems like that it is a real effect we're seeing. I would love to do this more in order to, really see the finer details. But assuming that denser tortoises are in fact approached more often, it seems that they have adopted a strategy of actively defending their burrow against intruders, right? So if you're visited a lot, it might be worth basically really ramming any visitor to hopefully reduce the chance, to hopefully discourage them from trying to invade your burrow in the future. Yeah, so perhaps in situations where you're like a peripheral tortoise, it's less important and more important to just kind of like block them from getting in the first place because you're probably not getting visited habitually. So yeah, conclusions. What did we learn from all this? So season is important to the movement of gopher tortoises. Their movement changes throughout the year. It's probably not important to the dispersion of gopher tortoises. The density of tortoises affects movement and burrow defense behaviors. Some future research would be to look at weather patterns more directly. What happens to hormone levels? I would love to be able to research that a little more in depth as well. Look at the size of tortoises and see how that affects things, and to see how they behave in different seasons and with different, basically different sized torties. So why does all this matter? Basically, many species of reptile make changes to their movements during the nesting season. Changes which have the potential to put them at increased risk of mortality. Females, especially like gopher tortoise females, are super important to their population, to maintaining a healthy population. By understanding the nesting season movements, we can do a better job of protecting them during this risky time. And understanding the behavior, it's beneficial because, of course, learning about any animal is great, but it also lets people see a side to tortoises that they otherwise would not see. And understanding the effects of density on movement behavior may also inform some really common conservation strategies for tortoises, which include like translocation and Head Start programs. So understanding how density affects tortoises would be really pertinent to those as well. I'd like to thank so many people. I got a ton of help throughout this project. First and foremost, Betsy Rothermel, for all the discussion, advice, and support, and basically just facilitating everything that I did. All the tortoise trackers that helped collect all that tracking data. Super, couldn't have done it without them. Some folks from the GIS lab, Julie and Viv, really appreciate it. They helped me a lot with a part of this project that did not actually make it into the presentation, but I'm still working on. Dustin Angel for loaning me his GoPro and letting me put it in such a risky situation, as well as letting me use his Photoshop license. I'd like to thank Jessica, Rachel, and Emily in the Herp Lab for giving me some helpful comments. All the interns just for being cool. My sister Rowan was also helpful. She helped me get through some sticky situations in R. And yeah, and of course, that goes without saying, all the gopher tortoises that helped me collect all this data. Couldn't have done it without them. So yeah, thank you so much, everyone.
Great job, Jack.
Thank you. Sorry, I went a little long there.
Well, I still see people sticking it out.
Good. Yeah,
we have one question. Can you see the chat, or maybe you can see? I guess you can't see Q&A. So let me read you a question from Andy.
Okay.
She says, very creative way to study tortoise responses to visitors. How did you make Torty's head move? Yeah, so
it's it almost happened accidentally. So basically, Torty, as you may have already figured out, is made of paper mache. I took a balloon, I did all that, and so to basically make the Torty's carapace more tortoise shaped, I used strings to pull it together, and I put his head on a stick that went all the way through the tortoise. And so his head was basically a stick that went through the tortoise. My hand went in the tortoise's butt, and I just wiggled it to kind of simulate tortoise head movement.
Okay, a couple more questions here from Christine. How did you determine what behaviors to emulate with Torty?
Yeah, so I love that. So basically, I was basically trying to do things to elicit a defensive response from the tortoise. So head bobbing, is often used as tortoises communicate with each other. It's like a great visual cue. When you don't have that much to move, moving your head can get across a lot of information, as well as literally just moving the position of the tortoise. It actually seemed like moving the tortoise close to the burrow entrance is actually what elicited the biggest response. And that is something I've seen in wild tortoises as well.
I guess that question was actually from Emily. I see it.
Oh, well.
Clarification there.
Yep.
And from Madison was asking, do you think that habitat type and or vegetation density would have an effect on the tortoise movements?
Basically, yeah, I totally do. Yeah, there's a lot of variation up at this study site, and if I were to keep researching this avenue, I would absolutely. I think that would really help color in some of the missing pieces.
In the chat, we have another question about behavior trials from Tori. She's wondering if you observed any behaviors that you did not expect at all or you couldn't classify.
Yeah, there were definitely a few that I kind of had to make categories for. Yeah, so all the behaviors that basically the list I started with was from a basically an inventory of tortoise behavior for desert tortoises. So one thing that happened is that a tortoise would just kind of twitch its head, and I'd be like, I don't know what that was, but it wasn't nothing. So I made up a category called twitch. It didn't turn out to matter a lot, but that was one instance where where I encountered something like that. Everything else actually surprisingly kind of fell into the same binnable kind of targets. Yeah, good question. Thank you.
I'll give people a last chance here to ask any questions. I actually was curious, wondering about if you had time to say repeat these behavior trials during the non-nesting season. Do you think you would have seen similar behavior patterns?
So that was something I wanted to look at initially. If I was going to be an intern here for another 2 months, I would definitely do that. But nesting season does, pretty much last through all that time. I do expect. The reason I would like to do that is because I think that they might actually be more relaxed before and after nesting. So anecdotally, I actually saw 2 tortoises in the process of nesting. One was before the trials, and one was actually in the middle. And it did seem like both of them kind of mellowed out a little bit after nesting, which was interesting, I thought. And I think, yeah, I think really testing that in a little bit more targeted way could be really informative.
Yeah, I agree.
Yeah.
Okay, one more here. Somebody asking, how long did each tortie session of head bob, weight, move for your whole the whole sequence of behaviors you presented? How long did that take, and how long did you wait before moving? Each step, I guess.
Yeah. So that's a good question. So that'll go in the methods when this is all written up. But yeah, basically I waited for 15 seconds between each behavior that I did on Tortie's end, either head bobbing or approaching. Was meant to take about 5 seconds, although sometimes it took between 5 and 10. Yeah, so the whole encounter would typically last about 1.5 minutes.
Right, they're tortoises, so you tried to give them some time.
Yeah, exactly. Yeah, the reason I waited 15 seconds is because sometimes you really gotta suss it out.
All right. I am not seeing any other questions in the chat or the Q&A. I see a lot of congratulations and good job. So
awesome. Thank you, everybody.
I guess we'll wrap it up.
Everyone coming out to watch me talk about tortoises. I hope everyone learned one thing at least during this presentation. Yeah, super excited to have presented and be done.
Yay.
All right.
Jack.
Yeah.
Thanks, Jack. Congratulations. And thanks everybody for attending today. Join us one more time in July next week for the Avian Ecology Double Feature Intern Seminar on Monday, July 25th. You can register on our Archbold website now or tune in on Facebook at 3:30 Monday. See you then.